Good morning or afternoon to everyone. Welcome to the grademetrix massless dozer solution seminar. We're going to go over our massless dozer solution today, and I want to thank you for taking the time to join us. Our webinar will be between 35 and 40 minutes long today, and we have a questions bar on the right-hand side of your screen. I've got several of my team members here waiting to answer your questions if you have them. Also, we will be happy to schedule one-on-one discussions with you at your convenience should you have additional questions. We're going to go over our Americas team today, the key features of the dozer system, the key system benefits, the technology behind our system, a couple of our system components in more detail. My partner Todd will then go through a in-cab simulation of our grademetrix software as being operated by the dozer operator. We'll talk about our US promotion, and then we'll wrap up with any additional question and answer to the right of your screen in follow-up. And again, we anticipate this webinar will be roughly 35 to 40 minutes. We really appreciate you taking time out of your day. We've got a very exciting thing to share with you, so let's get after it. My name is Jason Kilpack. I'm the Director of Business Development for Machine Control for the Americas. I've got over 25 years of experience in this space, working with different kinds of technology in regard to construction, engineering, and machine control. My partner, Todd Medine, who's also on the line, has got over 20 years of experience working not only various manufacturers representatives for 3D positioning and UAVs, but has a bit of a leg up on me because he started out in this business operating those big yellow machines. So Todd is a qualified operator for motor graders, excavators, dozers, and several other machines. He has the seat experience as well as the technological experience from how this stuff works in the field. We'd like you to consider us as resources for you. We'd like to answer any questions you may have and help educate you about our hemisphere grademetrix system. So what is this system? This is a massless 3D indicate dozer solution. There are 4 components outside of the wiring harness to install onto your dozer. It makes it very easy and very simple to install with an install time of less than 4 hours. All of these sensors are very rugged and they don't have any moving parts. This is a solution that can be put on any size dozer. It will give you track elevation, it'll give you blade elevation. As you can see on the upper right-hand side of the screen, we have an optional Pelican case that all of the foam fits into, and you literally have a display, our VR500 all-in-one appliance, and then 2 small sensors, one that attaches to your dozer blade and one that attaches to the rail of your frame of your dozer. We at Hemisphere have pulled together a group of people that have a great deal of experience in this business, and we have created a very simplified user interface, which we will go over in more detail with you shortly. This provides you dynamic cut and fill information anywhere on your job site. It supports all the industry standard file formats. So we don't have a proprietary file format system that some of the other companies do have. That makes us a little bit more agile to accept files from other sources, as well as doesn't prevent you from having files generated by either third-party model builders or, in fact, the engineers themselves that are doing the blueprints for you. On top of the standard file, industry standard file formats for engineered projects, we also have a very nice suite of in-field design functions built into the Iron One running the grademetrix software. That means that as long as you have a fixed position on your receiver that's on your dozer, you can build flat pads, single, dual, or multiple slope pads and roads directly from the seat of your vehicle without having any design loaded in it. What this does is it allows you to cut to either the design format provided from an engineer, or to cut to that design you've done as an infield design. It also allows you to take topo shots and to stake points. So if you've got a manhole or an invert or some other asset that's in the ground that you may need to cover up for a period of time, you can locate it with a dozer blade, take a shot on it, label it, and then go about your business. When you need to uncover that particular asset again, you can just stake out to it, uncover it, and move on. So what are the benefits? We've heard for some time about the enhancements of efficiency for 3D. There's multiple industry studies that show anywhere from 30 to 35% increases in efficiency. But ultimately, for us laymen, it reduces our labor, it reduces our fuel, it reduces our overhead of that machine on that project. We move material faster, more efficiently. Therefore, our machine spends less time moving. Our labor spends less time moving that machine, and that machine consumes less fuel. The benefit for you is the simplified interface. It's very easy to train. It's very easy for a new operator to understand it. Moreover, qualified operators in our business are incredibly difficult to find. This helps raise the skill set of operators that may need help, as well as new operators, to be more efficient and to move material with better accuracy on your job site. Having the industry standard file formats associated with it makes it easy, so you don't have to purchase additional additional software to format files. This will take in those industry file formats, as I mentioned. Ultimately, you are going to save on material movement on your job site, whether you're balancing a site, you're exporting material, you're importing material in. The less material you touch and move, the more money that you save. So imagine the non-smart machines that are dozers on your fleet today. Imagine improving them by 20% by adding this kit. Some of you may already run stakeless or have additional machine control on your fleet. This will help you reduce more cost and save more money. And for those of you who don't have this technology, it will allow you to run stakeless if you want to, and moreover, control your job site. You'll have the ability to manage your destiny and not have to wait for a third-party surveyor to come reset control or stakes if they've been blown over. So what makes this an earth-shattering system? It's the first time that anyone's offered all signals in all constellations in one kit for one price. On the upper right-hand screen, you'll see our sky plot from our dozer. There's 46 satellites being tracked and used in our solution. Below that sky plot, you'll see a competitive representation of what most machine control out there today is using, which is GPS and GLONASS, which gives us in the same area 22 satellites in view and use versus 46 satellites in view and use with the grademetrix system. The receiver in our kit is capable of tracking over 1,100 channels. If you're in this business and you understand what I'm talking about, ask your current provider about how many channels their machine control system tracks. If this is new technology for you, The key here is the number of signals that come down from different satellites and different quadrants of the sky directly impact the accuracy and the performance of your 3D system at the blade on your dozer. The more measurements you're taking from the sky from different satellites, the more accurate and the faster that solution will resolve itself. In situations where you're in a foliaged environment, such as tall trees, or you're in an urban environment where you have tall buildings adjacent to your site, the more signals from the more satellites from the different constellations that you can utilize in your solution will directly impact how well your machine works in that difficult environment. With the hemisphere system, you get all the signals, all the activations included in one price. You aren't going to be nickeled and dimed to add this constellation or these satellites, or add that constellation and these satellites for different costs. It's all singing, it's all dancing. This is the most advanced positioning system that is being put on machines today. It tracks the most channels, it runs at the fastest speed, and as you'll see in a minute, has some very interesting features in the hardware. So what is the hardware? This is a unique product in the machine control business. This system here, the VR500, is an integrated RTK GNSS smart antenna array. It has a primary and a secondary GNSS antenna that it calculates not only centimeter accuracy position, it also calculates very accurate heading. Inside of it, it also has a tilt sensor, a UHF radio, Ethernet, Bluetooth, Wi-Fi, a web UI to access your receiver, and it's all built at an incredible ruggedness spec. These receivers were designed for an OEM manufacturer in the heavy equipment business, and as per their spec, they've been shaken on a shake table at 50 Gs in each axis for 30 hours each in order to pass and be approved. This is a massless solution that takes a very simple installation. It mounts with a quick release on the roof of your vehicle. It can be removed with a single cable at the end of the day or the end of the job and taken off of your machine. It has that single cable that provides power from the machine for all of the electronics inside, and then all of the data that comes from those electronics goes down that same cable into the harness to the display. The Iron One display. This is the second primary piece of hardware for this kit. This mounts inside of your cab. It's built to IP67 standards, which means it's designed to be put outside. It could be in an open cab environment, get rained on, snowed on, operate as expected. It is a Windows 10 personal computer inside that's ruggedized. That means it runs all Windows software and can take advantage of Windows applications. We often utilize an application called Team Viewer to allow our dealer networks to support their customers with virtual terminal. They can actually go in and see your screen and help you manipulate your screen for support purposes. It has all of the standard PC connectivity that you would expect. An integrated Wi-Fi system, Ethernet. It also has a GSM equipped modem built in. It has a 3-year warranty out of the box. Very rugged and very nice visibility and very reactive to sensor input. With that, I'm going to hand this over to my partner, Todd, and he's going to spend a few minutes going through the application software as the operator would see it in the cab of the machine. Todd?
Thank you for the introduction, Jason. As Jason mentioned, I'm Todd Badine. I'm the Field Application Engineer for North America. Today, I will be running you through a brief overview of grademetrix. I will start with how the machine operator would use the system to grade with a dozer. Currently, we have two different ways the operator can set the machine up to get cut or fill information inside of the dozer cab. The first would be creating a job inside of grademetrix. This option will be used if the project has been designed by an engineer and the job has a set of blueprints or plans. These plans will be based off a known horizontal and vertical grid that the machine will have to match. I have an example of a job loaded and shown here. Notice all of the grade breaks shown on the side of the road in the cross-section view. This is showing you an image of a dozer blade as you're looking at it from the cab. The red is the surface that we're wanting to cut or fill to. If I zoom in on the plan view and start to approach the curb, you will notice that both the plan and the cross-section views change to reflect the location of the machine. Along with cross-section view, the operator can use the light bars located here on the left and right side of the screen to adjust the blade and maintain grade. Watch when I go past the back of curb. The light bar will now indicate that I have a foot plus of fill. Now, when I back into the road prism, it returns to grade. Grademetrix is additional views that will help the operator maintain grade. These can be found by using the icon in the upper right-hand corner. Some of my favorites to use is the plan, section, and profile view. If pushing towards a fill slope, the profile image here in the lower right will show the operator where to stop before overfilling the slope. Plan and section will add a large, colored cut fill area that is easy to see in your peripheral vision. And it will also display both current crossfall of the blade in a percent value and also show the crossfall design surface directly underneath the blade. The profile and section view is useful when you create your own designs and don't have to worry about any of these kind of grade breaks. For now, I will keep directly underneath the blade. The profile and section view is useful when you create your own designs and don't have to worry about any of these kind of grade breaks. For now, I will keep it on dual cut and fill. If the operator would want additional information like elevation or design elevation, it can be found in the information summary. Simply tap on the icon here to open it. It will display a multitude of different information that can be customized to show more or less information. It is important to note that the info summary is obtaining that information from a specific part of the machine, shown by this green triangle in the cross-section view. It is now set to blade left. If we wanted to know what the elevation is on the right side of the blade, you just have to click and hold on the blade to change it. Now the summary data will be referenced from the right side of the blade. To close the summary, click on the same icon that opened it. When models are created for a job like this, it is generally built to a finished surface. This would be top of asphalt, concrete, or gravel depending on the job and the materials. The operator would have to offset the thickness of the material to get to subgrade. We can do this in a few different ways. Below the left light bar, you will see the up and down arrows. If we click on the down arrow, you'll notice that the offset numbers change by 1/10 at a time. The upper number here is showing you how much cut or fill you have, and the lower is our offset. The cross-section view also has a new line going across it that represents our new grade. If we have a large offset number or a number not divisible by 1/10, we can manually enter the offset by clicking and holding on the light bar. You can manually type in the offset here. A negative number means that you'll go lower or cut more. Step is the amount each vertical offset button will add or subtract when pushed. If the job has more than one vertical offset, for instance, one for subgrade and one for top of rock or finish course, you can save the current offset by clicking and holding the preset, making it easier to switch in the future. Guidance lines will provide us with station and offset from a selected line. This will work with any of the CAD lines that you bring in under the line work file. From the main screen views, click and hold on the line that you would like to get the stationing and offset from. A new menu will appear. Select the Use Guideline checkbox and select OK. We will now see stationing and offset while I navigate along this chosen line. Now that we know how to use grademetrix with a job that's already been loaded, I will show you how to create a job and describe the files needed to start it. The icon at the top left is how we access the menu. The very first option is New Job. First, we name the job and click Next. The first file it is asking for is a localization. The localization file is gathered by using a rover and site metrics. The job or project will have known control points that are established by a surveyor in the early phases of the design process. Sometimes you will find the northing, easting, and elevation of the control points on the plans, or you will have to request them from the project owner or general. When you get the control information, you will have to shoot each point using a rover. All this does is equate a specific lat long and height to a known northing, easting, and elevation. Once you complete this, you can save it to a thumb drive and bring it into grademetrix. We also have the capability to bring in a calibration file from Trimble Construction or export the point data needed from TopCon for customers with mixed fleets. The second file is line work. This is the lines that you see in the plan views and are obtained from project engineers or model builder. For line work files, we accept DXF or DWG. I now have the localization and the line work file selected. When I select next, it will ask for the third and final file, a surface file that contains the project's finished grade attributes, elevated to the correct elevation to form a three-dimensional surface that grademetrix can read. These can be built using the CAD data or line work file from the engineer and numerous different CAD packages, or nowadays it is inexpensive to get built by a model builder. We accept most file types like DXF, DWG, XML, DTM, among others. Once you've selected the surface file, click Next and make sure the units are set correctly. We select Next one more time to see the localization file in text format. If bringing in a Trimble cal file, you will see the calibrations residuals here, showing how accurate the localization will be. Once satisfied, finish the job. Again, the above process is used for projects that have been engineered and have a CAD file or set of plans. There are times when the customer will not be on an engineered site, or that site will need a redesign done. We have included a few tools that will still allow the machine owner to use grademetrix in this case. You do not need to localize the site or have any files for this to work. All you would need is RTK corrections from a base or internet corrections from a BRS network. Setting a base on an unknown point and making it broadcast is easily done within SiteMetrics. From the main screens, go to the menu and select Field Design. We have 4 different types of field designs that we can use. Notice that every type of field design can be named and is automatically saved for future use, making it easier to switch back and forth between saved designs. Flat pad will create a pad at the same elevation on all sides of the machines forever. To use this, first drive the machine to a known grade or stake. If the stake has a cut or fill to the desired grade, we can fix that later in the vertical offset menu. Give the pad an appropriate name and select Record in the lower left corner. Once it is recorded the elevation, select Finish. You will now see the color of the surface has changed to green and you now have a flat pad. We can still see the job's design surface in red, but if I drive over to a portion sticking above the new pad, it will still give me the cut or fill to the pad and not the design surface. This will make it easier when doing redesigns in the field. If the stake that you benched on at the beginning had a cut or fill, you can easily add it by clicking and holding on the light bar and typing it in the offset. The second design is hold slope. This is used in conjunction with guidance lines to allow a particular percentage off a line based off the position of the blade and the guidance line selected. To select a guidance line, tap on the line you would like to use and check mark the Use Guideline box and press OK. Now, position the dozer with the desired blade cross slope. The emulator does not allow me to angle the blade, so I will only be able to show you using a 0% crossfall. If I go back to the field design and hold slope, I can press Record. And now Finish. You will now see a new surface color holding that 0% crossfall at the guidance line's elevation. This would be useful for road slope redesigns or if a contractor needed a place to get rid of some extra material. The third option in field design is slope pad. This will do anything a dual plane laser can do, useful for parking lots, tie-ins, and 2 known areas. To start, position the machine on a known grade or stake and facing the direction of the proposed main fall slope. Now press Record. And now Next. You would now drive the dozer in the direction of the main fall heading, and you can also place the blade down to establish main fall percent between the 2 points, or you can type it in manually if needed. I cannot move the dozer in the emulator in this menu, so I will just type in the bearing, distance, and slope, and select Record. And Next. Now it's asking me for a desired cross slope. I will give this positive 5% so we can see it when it's finished. When I track ahead, you'll see the existing surface fade because of the increased slope while moving forward, and we now have a 5% crossfall. The last field design we have is ramp. It is very similar to slope pad, but it will give you the option for a second grade break or 2 sloped pads based off the line that you record. Think of a B-ditch or a crowned road. Just like slope pad, I will start with a known grade, elevation, or stake, and start with the machine facing the proposed main fall direction and press record. And next. You would again drive in the direction of the main fall to establish the bearing and either use the blade to create the main fall slope or enter it in manually and press record. Since I cannot move the machine in this menu, I will just type in the bearing, distance, and slope and select next. Now it is wanting me to build a cross-section template. Side of center is used to tell what side of the center line I want to project my new lane. I will give this one a 12-foot width and a -2% fall. I'll do the same for the right. You could also add additional lanes to the template if needing, giving the operator the ability to build a complex model with ease. Once satisfied with the template created, just push next and then finish. You can now see the crowned road that we have created. Inside of the Topo submenu, the dozer has the capability to manually record single points and also record points based off of predetermined distance or time automatically. You can also save any points recorded to a certain file. For example, you could have a file for utilities, existing topo, or manholes. You can also add a code description to the point by using our default selection or add your own. In the main view of topo, you would just have to choose to shoot a single shot for a manually recorded point, or you can start the auto topo using the established values in the setup menu. There's a second page to our menu. This is used to change the radio channel or adding credentials to a VRS network. This is also where the install wizard is located. Equipment setup will guide you through the install process. First, name the machine and pick the units you are using to measure the machine with. The next menu is asking you for the dimensions from the center of the base of the cutting edge to the center of the primary antenna. This can easily be achieved using a rover. The chassis is for scaling the image of the dozer in grademetrix. The blade measurements are also very easy to measure. The next menu is used to tell where the sensor is located and which way they are facing. On the dozer, we have one sensor located on the cab and one on the blade. The sensors are shaped like an arrow, so it is easy to identify the facing. The writing on the top of them will tell you the position. The final screen shows us the measurements we inputted. Verify they are correct and finish to save. The final portion of the install, we will be calibrating the sensors. The wizard does a great job walking us through it. Park on a hard, flat surface and then mark the blade. Then press record. And next. Notice how the image has changed? We flip the dozer around and park the blade on the painted line and press calibrate. And finish to save. The install process is now complete. If you have any questions, please reach out to me personally, or you can ask them in the chat box now. I will now give it back to the presenters to answer any questions. Thank you.
Thanks, Todd. As you can see, we've got a very easy to use interface with a lot of functionality. So what's the real summary here with the dozer system from grademetrix? We're trying to give you the maximum return on investment for your machines. And we're trying to bring that efficiency to machines that you may not consider adding electronics to that are part of your fleet. Whether you're new to 3D or you've already used 3D in the past, we've had quite a few questions come up so far from, it looks like, someone who's got some pretty good experience. This is an added value to your operation. We're offering a world-class performance dozer system that has an industry-leading 3-year warranty. It has all of the included signals in it out of the box. There are no hidden activations. There are no additional upcharges for different signals for you to buy later down the road. We've got a very attractive price point. And we'll go through that in just a little bit more detail to follow. This has an incredibly fast installation and simplified calibration. It will allow you to have an intelligent machine on your job site, quick and easy. Software updates and firmware updates are included with our system. They are not an annual fee. They're not something that's a gotcha down the road. As I said, we do have the best warranty in the business. You will not find a maskless dozer system at this price point with a 3-year warranty with this kind of performance. Our promotion for America, we're working for our friends in the Canadian market as well. We haven't finalized those terms yet. This is a 27-month total lease with 90 days deferred payment, 0 down, 0 interest, and then 24-month terms at less than $1,000 a month for a dozer kit. If you do the math just on the fuel bill of a mid-size dozer, that's probably less than the fuel bill of one of your machines per month to get 20% improved efficiency and reduction in material costs, labor costs, and faster job completions. We're real excited about bringing this system to you guys. We want to be a reference for you. We have a similar system for our excavators, which we're going to be having on this Thursday, the 14th at the same time, which we'd like to talk with you about, with similar financing for the United States. As well as on Wednesday, we have a site metrics system that we use to control our sites, which is either a supervisor truck or a manned rover to do topos and volume calculations. As I said in the beginning, my name is Jason Kilpack. I'm the Director of Business Development for Hemisphere Machine Control here in the Americas. We'd like to be a resource for you. I'll now transition over here to the right-hand side of the screen for a few minutes. If anybody would like to have any additional questions that might have come up during the presentation, please, by all means, ask them. Also at the top of the screen above the chat are the handouts for the different systems that I've mentioned today. We really appreciate your time and your consideration, and looks like we've got quite a few good questions going here. Anybody else that's in attendance that would like to answer or ask any questions, please feel free. Okay, well, it looks like we've got a slowdown here in the questions box, so I'll go ahead and look to wrap this up. We really appreciate all of you that have joined us today. If we can in any way help you moving forward, we would like to do so. Appreciate the time. Stay safe out there, and we'll look forward to seeing you maybe on a couple of our additional webinars this week.